Overlay networks on Bitcoin have been talked about in theory for a long time. And yet, for a number of years now, we haven't had an actual implementation of something that is universally recognized as an overlay network. And so we should set up some definitions to begin with so that everyone understands what is an overlay network. And then we should figure out what implementations of actual code and working software are capable of delivering overlay networks on Bitcoin. I define an overlay network as a system that works on top of the Bitcoin transaction graph to facilitate functionality that is not inherently present or compatibility with protocols that are not inherently defined by the base level Bitcoin network. And so that's a very specific definition, and it requires a number of things to be set up at the base layer so that overlay networks can function on top of Bitcoin properly. The infrastructure for running things on top of Bitcoin, such as simplified payment verification, needs to be properly implemented before we can even begin to consider overlay networks as a working solution for any real problem. I would say that in order to have an overlay network, the infrastructure underpinning Bitcoin needs to be reliable and well understood by the people who use it so that people can take advantage of the scalability properties that are present in Bitcoin and leverage the UTXO structure of Bitcoin most effectively for their use case. When people don't understand the concept of defining tokenization in terms of Bitcoin output scripts and the satoshis that represent the tokens contained therein, then it becomes difficult to build on top and to add another layer of technology. So I recommend going through and developing your understanding of Bitcoin as a UTXO-based tokenization system, and also understanding concepts like simplified payment verification so that you can best equip yourself to think through these processes as I define them here in this video. Once you think you've got a firm grasp of the underlying concepts that make Bitcoin work and that facilitate truly scalable architectures on top of Bitcoin, such as the peer-to-peer exchange of transactions versus relying on indexers or miners to provide blockchain data to all parties, and things like the furnishing of Merkle proofs for transactions so that when peers exchange, they have the capacity to independently validate the veracity of a transaction with only the data provided by the sender, and also the capacity to enable peers to exchange value directly and to authenticate directly over a communications channel that they themselves establish and maintain. Those things are important premises on top of which Bitcoin overlay networks they're gonna operate on top of those things, right? We need to get people to understand peer-to-peer authentication using certificates and identity so that peers can interact, peers defined in the Bitcoin sense of the word, right? Being actors who create Bitcoin transactions and facilitate exchanges of value among themselves, using Bitcoin in the way that it was intended, defining the terms under which contract execution can proceed within the context of predicates, Bitcoin script output, programs. And those are some of the things that need to be defined before we talk about overlay networks. So my recommendation is to start with the simplified payment verification process. Go understand that so that you can understand how Bitcoin is supposed to work. take a look at tokenization, and also be conscious of the mechanism by which peers can exchange information in an authenticated manner. With those bases covered, we can now proceed and ask ourselves, what functionality would we want to put onto an overlay network in Bitcoin, and how might that functionality be architected in a logical way? So I have a whiteboard here that I can try to draw on to illustrate some points when necessary. Let me pull it up, so just give me a second. I would say that one of the more important things that people might want to do on top of overlay networks is related to the exchanges of value necessary in a micropayment-based application or economy even, right? So for example, what if there was an artist who wanted to publish a song, and then there were people that wanted to listen to that song and pay the artist using a micropayment system whenever the song is listened to, thus compensating the artist for their work, and maybe also compensating the people that provide the infrastructure, the user interface, the hosting, the data storage in the data center, the bandwidth to actually make that song available. So compensating all the parties involved in that transaction. We could define an overlay network that does that. And so I'll go ahead and write up here maybe the tempo. And pardon my handwriting. I'm using an iPad here to draw everything. But we can define here the tempo overlay network. And I think that there are some things that can be done on top of Bitcoin to make a structure like this work in this context. So let's go ahead and think through what might we need. Well, we're going to need to define a couple of different things, right? We're going to need to have a structure or some mechanism of representing sort of a song, right? And we're going to need a mechanism or structure of representing as well as conveying across between parties the payment, right? So there's the payment and there's the song. And those are really the base level structures that we can start with in an overlay network. Now, in a UTXO-based token system, tokens are going to represent the things that are valuable. So we need to start defining these things as tokens so that people can represent them and act upon them as desired, right? And that means who has the right to update a token, who has the right to receive it, to send it, to interact with it in any given context. So why don't we start there? There are song tokens then, and there are payment tokens. Now, how do we represent this in Bitcoin? I'm going into the theoretical again and the abstract like everyone always does when they explain these things. Well, let's stop doing that. Okay. There exists an output script that is part of a Bitcoin transaction. And that output script contains various stack element pushes. So we push data onto push some elements of data onto the stack in the Bitcoin script interpreter. And that data represents a song. So what data do we need to push onto the stack at the beginning of our output script to represent a song? Well, let's push the name of the song, the identity key of the artist, and maybe a link, an album art link, right? So like a hash, for example. You could use the NanoStore hash-based content delivery network, which is an overlay itself on top of Bitcoin. But you can push some link. It doesn't even matter. It could be just a web link, an HTTP URL. So let's just keep it simple and say those are the three things that are part of this song, right? So we got the name of the song, the identity key of the person who made it, and the link to the album art. And those three get pushed onto the stack in a particular order. right? Now, to denote this as a song, you could put a prefix on the stack before that. So now there's 4 things, right? First, the prefix, name, identity of the artist, and then the identity key of the artist, and then the album art. We also need a way to pay the artist, right? We need a way to contact them, right? How does somebody interact with this token? So let's define this, okay? So another thing that gets pushed on the stack is going to be the URL to a server where the buyer, the listener, the person who wants to listen to a song, can contact the server and facilitate payment over a peer-to-peer communications channel between the listener and the server, who is the agent of the artist, right? And of course, now we get into, well, what if the artist wants to change the server or run their own server? It's all possible to do that. But we need some server that someone can contact in order to exchange a payment. And we need somebody to sign for the receipt of that payment as well, for good record keeping. So we also push the URL of a key server, right? Why are we calling this a key server? Well, we'll get into that when we get into the architecture a little bit. So let's go ahead and write a few of these things down on the whiteboard for what might be in a song token. I'll bring back up here the whiteboard. And so the song, right? We've got the name, we got the artist, we got the artwork, and we got the URL. And then we've pushed this data onto the stack in our Bitcoin token now, but we haven't necessarily been able to do anything else, right? Like, we need to actually make this into a token, something that represents something of value, this song, and say who has the right to change these things. Because the artist is going to want to be able to change the information associated with their song, right? What if an artist wants to change the artwork? Or maybe they want to change the server responsible for hosting this song and making it available. We're going to need to provide a mechanism for updating this song token. So we know that the artist has a key, right? It's the identity key that we already know who the artist is, pushed it on the stack already, right? So in order to facilitate the updating of this token, now we could code up in Bitcoin script itself all of the constraints under which this token could be updated by the artist. We could say, well, anybody that creates another token that does XYZ could update and spend, right? And only in that particular case, using like a push TX methodology inside Bitcoin script. But that may not necessarily be the best approach. There might need to be some changes that weren't necessarily defined in Bitcoin script itself. Maybe the artist just wants to take down the song and not have it anymore, spending that token finally. And yes, you could code this in at layer 1, but the point is that sometimes you don't code things at layer 1. Sometimes there are things that aren't necessarily part of a layer 1 system and aren't enforced by the Bitcoin miners. The point is that when the parties involved exchange data or update data, there is an understanding between those parties about what is the current state of the system, and Bitcoin facilitates the record-keeping mechanism as well as the stipulation mechanism for some of the criteria under which that can happen, and some of the security as well when you do public key cryptography properly and keep your private keys safe. But in this context, we define an open-ended system. So what we're going to do here is delegate to an overlay network, right, the mechanism by which this song can be updated. So to do that, we push all this data on the stack, and then we drop it immediately. And why would we do that, right? It's like, what purpose would you have in doing that in Bitcoin? You're wasting right? You're wasting something, it seems like. But if you think about the purpose of this token, right? The purpose of this token is not to push things on the stack and to do things in Bitcoin script for the sake of Bitcoin script. The purpose of this token is to use Bitcoin in the most effective manner to facilitate a representation of what this token is and what it does and how it works. And by putting that information in the stack and then dropping it, we actually allow that to happen. But we also want a way to represent the update that can happen to that information. So after we push and drop, we can put a lock on it and basically say, okay, there's some representative number of Satoshis in this token that represents this song. And whoever has a certain public key can spend these tokens, update the song, maybe in that same transaction, create a new token that is the updated rendition of the song. And there's nothing in the Bitcoin layer system that actually facilitates or demands that this happen. All the Bitcoin system, the Bitcoin layer stuff demands is at that layer, someone spent this output and they provided a valid signature, right? And if that happens, then the spending transaction is free to do what it will with that input. Put it into a new output, maybe with updated information, or delete it. Either way, the point is that an overlay network can be responsible for knowing about those requirements at that level. And that the people who participate in that overlay network can be responsible for enforcing those rules, knowing what those rules are even, and then facilitating this exchange of value that is happening, or this token and what it means, right? And its sort of utility within applications that are using it. So a music sharing application might be a node on this overlay network, might run a copy of the rule set for this overlay network and denote that within that particular application, certain things might happen. So that's how we can do the beginning of this, right? We can have a UTXO with a push and a drop. So it pushes all the data to make record of it, and so that it's there for the overlay network to see, but then it drops it. And that's not because of Bitcoin script, right? Bitcoin script isn't the point. The point is the overlay network now has information that otherwise it didn't have. And then Bitcoin is used to unlock and transfer using the UTXO structure to the next owner, or to no owner if it's been spent, right? When the spending transaction comes along with a valid signature. So the song token also has a lock on it. And now we'll get into overlay network design and how we can actually facilitate this. Let me switch back to the whiteboard here. Just pardon me for a second. So we'll go back to the whiteboard. So it's got a lock on it. So the token is locked and the artist has the key. And when the artist wants to make a new token, then the artist is going to be able to do that. And so the artist can facilitate updates to the songs they create. For example, pushing a new URL in place of the URL that's there already in the spending transaction, right? But now we need to talk a little bit about, let's do the payment, because the payment is really simple. So when a listener wants to listen to a song, we kind of know what a song is now, right? When a listener wants to listen to a song, listener is going to contact the URL for the server, right? And so when that happens, the listener is going to contact that URL, and it's going to get some information, and that information is then going to make it into, right, this transaction. So the payment is going to be the thing that the user uses to send funds to the artist, obviously. So that might contain some Satoshis, right? So the payment to the artist might contain maybe the TXID of the song token, the current rendition of the song token. And that way we know what song this artist, this listener is currently paying for in this context. And the payment is also obviously going to contain some amount of money that is being sent to the artist, and it's going to be locked. It's going to be locked to the artist, or locked to the. It's going to be locked to the server, right? The server that it contacted. So it's saying that here's the song I'm paying for. That's important. But then also, in addition to all of this, it's also saying here is the here's the amount of money, and here's where it goes, right? So now we can start to define the rules for this server and for the overlay network itself, because now we have our basic structure in place, right? So the basic structure is there's songs and then there's payments for those songs. And how might we go about architecting that? Well, there are a number of different ways of doing it, but the payment is represented by an unspent transaction output which contains value destined for the artist or for the server who runs it, for the people that made the song available. And then the song is an unspent transaction output that represents the current state of that song and the information associated with it, so that the listener could pay for the song when required. So now let's go ahead and actually figure out how these things are going to work. I'll clear the board here, and I'll then go ahead and switch back to this for a sec. Okay, so now we know about the basic structures. When the artist publishes a song, we know exactly how the artist is going to do it. It's going to create an output script with pushes of the song title, that information we talked about, the artist identity key, the album art, as well as the URL where the listeners can go to listen for the song. That output script is now in a transaction with 1 Satoshi or some representative amount of Satoshis for that song, right, to convey that it is valuable and that it is a token that can be updated in the future. And then it's going to lock it so that the artist can spend that token and recreate a new one later or something, right, if desired, or not, and then have the song be deleted. So the artist creates this and makes note that this is a song that I created, makes special note of that particular transaction output. I'm not going to accidentally spend it or something, right? And now that exists. How does the artist let anyone know about this? Let's think about it a little bit, right? There are overlay network operators that might emerge to track these kinds of things, right? So, for example, let's set a rule that when the artist ever spends that token in the future, then that should invalidate the previous state of whatever was in the previous output. And then if the spending transaction contains an output with information in the same format, then of course the new output is going to replace the old one and become the new state of what this song is. But if it's spent and there's no valid output, or the output contains corrupted information, then the person who keeps track of these outputs on this network is no longer going to accept it as valid, and it will not be tracked any longer. Any subsequent spends would not be recognized because the previous spend was not recognized. So now we're enforcing this rule at the overlay network level, not in the Bitcoin script level, but at the overlay network level, that essentially stipulates the validity of these types of tokens. And so that's very important, because it means that when multiple nodes, I say nodes, when multiple overlay network operators agree on the state of the network, or the state of the particular tokens, as well as the rules by which those tokens are constrained, then we have a way to enable people to interoperate in a federated way. We don't need one coordinator. When everyone agrees on the rules, just like in Bitcoin itself, right, the network can be emergently federated, right? Not one single party controls everything. In some overlay networks, one single party will control everything because they will dictate the rules by which the network can operate, and maybe if there's changes to that, they'll dictate those as well. But it is certainly possible to create federated overlays when the rules don't change, when everyone follows the same rules. So now there's these people that keep track of these outputs, and then we can delegate a specific interface for how this can happen. There's an interface where all of these network operators, these overlay network operators, they take in new transactions that are tagged with a particular identifier which says this is the specific overlay network. Maybe it's a songs overlay network that I want to deal with. And then here's a pertinent transaction that I'm submitting and saying this transaction mutates this one or even multiple overlay networks, right? As part of this submission to the network operator. The network operator will then take the transaction, apply the rules. It'll know about the current state based on previous submitted transactions. And the other thing is that because it's on top of Bitcoin, it's going to rely on the network of Bitcoin miners to prevent things like double spends or invalid transactions being submitted. Only valid Bitcoin transactions, meaning that when you do things with UTXOs, unspent transaction outputs, and when you redeem them and then later spend them and then later redeem them again, you're going to have a deterministic ordering for those chains of spends. And you're going to be able to apply complicated logic that depends on the current state of a UTXO, what the next one can be. And you can encode complicated rule sets using that system. So these types of networks can be operated by federated groups of servers who can then gossip to one another and synchronize the current state across them. And everyone will be on the same page because the miners either accept a transaction or they don't. And if one of the network operators falls behind, perhaps wasn't aware of an intermediate spend in the UTXO spend chain, then, of course, they'll either request it from the person submitting the transaction, or they're out of sync, and they need to find that transaction from one of the other network operators. Protocols emerge for doing that as a result. So these network operators operate these networks, and the networks themselves have various components, because this is just half the story, right? Now an artist can publish a song and everyone can know about that song, and then when the song gets updated, everyone can know that the song is updated, everyone on the network. But how do we get information out of that network? How do we extend this? How do we make a dynamic system that actually enables multiple networks to be run by the same network operators, enables these complicated rule sets to be defined succinctly, and also facilitates the looking up of information that is present on an overlay network? That's where we have to start thinking about the meta architecture, right? How do we architect a system by which good overlay networks on Bitcoin can be architected? And that's where we start getting into some of the ways that people can design things and some of the different methodologies that can be employed. But one approach is to define the concept of a topic manager. So a topic would be songs, for example. And then the manager for that topic would be the songs topic manager. And then when the overlay network operator receives an incoming set of information associated with a topic, so an incoming transaction tagged with that songs topic, then the network operator is going to send that information off to the topic manager, who's going to apply the topical rule set and say, well, given this transaction, it's spending a certain input which was previously part of this topic, and so we know that, right? And then is this spend valid according to the rules of the topic, or we know that input's gone because it's been spent, but what happens with the outputs, right? Which outputs constitute valid additions to this network, right? So given a transaction, and given that it may or may not have spent some previous state from the network, some previous output, which was previously current state of the network, right? Now it's been spent. What does that mean? That's what the topic manager gets to decide. The topic manager of an overlay network gets to decide, right, which ones are valid. So with the song, we have, well, given that there is no previous spends, we make sure that one of the outputs is a valid song according to the rules that we defined, right? First element must be the song name, second element must be identity key, third element must be the link to the artwork, and the fourth element must be the URL. If it spent a previous song, then we should make sure that, number one, the identity key of the artist is probably going to need to be the same, although maybe that could change. I mean, that's a specific rule of the specific topical overlay network that we need to define. So the topic manager is responsible for implementing and properly tracking tokens on that overlay given the transactions that update those tokens as input. And given the previous spends, right, that are now being consumed, it can decide what the next state is. It'll return a list of transaction outputs that are valid additions to that network. The topic manager maintains the valid sub UTXO set, right? The valid subset of Bitcoin UTXOs that are part of this overlay. And that's how we define the first part of overlay networks. So multiple network operators that synchronize transactions as well as running the same topic manager for the same topic on their network will arrive at the same UTXO subset for that overlay. And now that's synchronized. So when artists publish songs, those constitute valid additions to the song's overlay. What about when payments are sent? Well, I need to get that payment sent so that the artist receives it, so that the server operator receives it. I submit that payment to the same overlay. And the topic manager for that overlay is smart enough to know the difference between a payment token and a song token. And it's going to accept both. So that both kinds of token, both payment tokens and song tokens, are now part of this same list of outputs, of UTXOs that are on this overlay. And both of those are going to be returned, right? So given the transaction as input, and the things being spent, which that's not relevant for payments, but it is relevant for songs if they're being updated, right? Given both of those as input, it's going to return a list of the outputs from this transaction that constitute valid members of the overlay. So valid payment UTXOs that actually contain a high number of Satoshis, actually a significant number, right? Paying for the listening of the song, those are going to be part of the overlay as well. Now, we run into a few obvious problems, right? Artists can publish songs, and now the network operators have this list of songs and this list of payments, and they're kind of intermixed. And that's not a good thing. We don't want someone searching through a list of songs and then finding a payment somewhere in there. That's not how apps are supposed to work. But that's where the second category of meta architecture for overlays comes into play. So overlays have topic managers. UTXO-based overlays have topic managers. And they also have lookup services. So a lookup service, once a topic manager has decided that a certain given UTXO constitutes a valid addition to an overlay, or when the overlay network operator concludes that a previously existing member of the overlay, a UTXO, has been spent, those two events, the addition of new and the removal of old overlay UTXOs, those two events are sent to lookup services. So the lookup services are dealing with network-specific data formats and network-specific storage mechanisms, data stores. So these lookup services, for example, let's think of the one for songs, right? I'm a song lookup service, and I get an incoming UTXO. I'm going to look at it. I'm going to see, okay, this one is a song. So I'm going to insert it into maybe, I don't know, an SQL database, a Mongo, a Neo4j graph, whatever it is. And that's specific to the song overlay, right? So songs overlay can do this in any way it wants. And it's going to insert, the fields, right? So song title, that'll be a field in that, a column in that SQL table if you're doing it that way. Or a key in your MongoDB document, right? Or your Neo4j node. And you'll make certain ones indexable. So you have an index and you do, all your search-based things, your fuzzy finds, all that stuff, right? You'll set all that up for your specific use case. So that, right, now you have data sets that are specific. If you decide that this is a song, well, it goes in there. If it's a payment, it goes into another table in your database, right? And then when it gets removed, well, now I know this payment has been accepted, it's been captured, redeemed, used by the recipient. So I go ahead and remove it, so it's no longer sitting there in my table. So when someone wants to look up a song, they can use the lookup endpoint, which is hosted by network operators. So network operators have a submit endpoint for notifying them of new transactions and particular overlays. Then they have a lookup endpoint, which notifies them, which requests to receive information from an overlay. And so when I, as a user of an application, want to receive information from an overlay network, I will use the lookup endpoint from the network operator that I'm connected with. And I can connect with multiple if I was so inclined. And I would say, here's the lookup service provider. I want to use the songs lookup service provider. And then within that, there's a query, right? So you provide a provider name and a query. And then for each provider name, they get to decide how their query works. So I could say, I want to search by song title, and the song I want to look up is, I don't know, some random song. Can't think of any right now. So we'll perform a lookup using the lookup service, and the lookup service will then take that query and apply it to the specific data sets, the data stores that it has created specific to this network, and then return a list of responsive UTXOs from that overlay that are current members of the overlay that respond to that lookup. So that same lookup service, because it knows about both songs and payments, could respond differently to another query that says basically, hey, I'm an artist, here's my identity key, what payments do I have available for redeeming? Provide all the UTXOs, they go unlock them, use them, submit the transactions that spend them, and now the overlay removes those from the network, and now they're not on the list anymore because they've been spent. And when someone searches again, they won't show up because the lookup service was notified using that event, and it got them out of the database. So lookup services facilitate access to data that is stored within overlay networks and enable various participants in that network to make very open-ended queries that are defined by the specific lookup service on the specific network. And then why don't we extend this a little bit further and just say that, not necessarily it is going to be the case that one lookup service must map equally to exactly one overlay network. Maybe one lookup service wants to try to get good at indexing and categorizing data across multiple overlay networks that are hosted by the same network operator. So just pass them the events, right, for any addition or spend from any of the networks run by a particular network operator, and include the particular topic of the particular event in that event payload. And then there you have a system that enables people to operate overlay networks without worrying about, well, are my lookup services compatible? Because the lookup service knows which topics it's compatible with. It'll see it in the event, and if it's not compatible, it'll just drop the event and not process it. So then anyone can use any supported lookup service to look up data from networks of their choosing and have that data represented as a list of valid UTXOs that are currently part of that network according to this network operator. They can then use those as inputs if they have authorization to do so. They can use them to represent information within applications, such as I might go and decode that output script again that had the pushed song title and album art and artist and everything, and I might just make a list of songs in my search results, right? Or when I click on one, I might then go ahead and submit a transaction that is a payment. I might then also submit that to a key server, which recognizes that payment, provides me the key to unlock the song, lets me listen to it, etc. But the overlay network can track the payments, and the overlay network can track the songs. And it can facilitate access to both whenever needed. And this is just one example. So Bitcoin overlay networks generally will have a way of tracking which outputs are valid members of the overlay given the context and the places where outputs are spent and the contents of those output scripts and the context in which they were spent, the circumstances, right? Those circumstances are defined as protocol rules specific to the given overlay network that you're talking about. And then you have things like lookup, where now anybody can find any set of UTXOs they want, given the lookup service is able to do it for them, right? With an open-ended querying system, and any of the overlay network operators that support a particular lookup service can respond to a query. Monetization of these things, because we're all Bitcoin native now, can be done at a lower layer. You can use a system like Packet Pay, which is a system that Babbage has created, for monetizing data access on top of overlay networks. And you can use a system like Authright to authenticate communications channels. And this system, the system for creating overlay networks, is called Confederacy, because it's a federated network of overlay network operators who host whatever they want and synchronize data among themselves, applying common rule sets to the topical UTXO sets to arrive at topical UTXO sets, specific sets of Bitcoin transaction outputs that are responsive to particular requirements that are stipulated by protocol rules at the overlay network level. So you can do a lot with this, and I've just gotten into a basic example with these songs here, and what might be done with a more advanced use case. You could do things like multi-stage, multi-phase like payments across escrow systems, where you just check whether the current UTXOs that are happening are in order and are going ahead as they should, or using particular keys as they should, right? Or containing certain information as they should. And then when that happens, you constitute valid updates to the overlay and replace the UTXOs as necessary. You can also do non-finals. So you can submit something to an overlay network for tracking, even though it's a non-final transaction. And then, of course, you'll have rules that apply for once it becomes final, or what if it gets replaced with something with a higher sequence number in Bitcoin. You can do a lot with overlays. In fact, I would say that most of the use cases for the future in Bitcoin are going to be defined on top of these UTXO-based overlays. And so I just wanted to cover some of the basics and what can be done. The last thing I'll talk about here is something that's going to happen in the future when there's multiple overlay network operators who run the same data and that have emergent needs to synchronize, right? These needs emerge for synchronizing state across themselves. There's going to be a meta overlay network, an overlay network that is for overlay network operators to advertise that they host particular topics. And that'll be called the Confederacy Host Interconnect Protocol, or CHIP. And that protocol will enable different overlay network operators to negotiate synchronization of data among themselves and to advertise the availability of particular topic-based hosting, right, to the wider world. And that'll facilitate a purely federated system for coordinating and accessing and using overlay networks on top of Bitcoin. So that's how that works. That's how overlay networks are going to work on top of Bitcoin. It's certainly something that does require more, it's going to require some coordination in our industry. It's going to require some more technological development and research, but I think this is the basic concept, and I think it's going to work very, very well. So I've made a write-up. I've made a write-up on the Confederacy system for defining overlay networks on top of Bitcoin. I now have this example in this video that discusses it. If you'd like to read the write-up, which contains specific technical details on how these things are going to work, I mean, it doesn't define the actual specifications for how systems connect yet, but that's coming, right? We're going to be releasing specifications for synchronizing overlay networks on top of Bitcoin fairly quickly. I would say this year, 2023. And I'd like to discuss this further with people. If anyone would like to come on this channel and just ask questions about these things, we can discuss it further for the benefit of the people in this industry. And I'm happy to engage on this topic. I think overlay networks are going to be an extremely powerful thing in the industry, and they're going to facilitate a lot of functionality that simply isn't practical to do directly and entirely in Bitcoin script. You can do a lot on the higher layers, and when protocols are standardized, when systems interoperate, I think everybody wins. So thank you very much for taking the time to watch this longer video here and understand some of this stuff. I'm happy to answer anybody's questions about this topic, and so reach out. You can check out Project Babbage. You should read our developer documentation if you're a developer, which you probably are if you've managed to watch your way through this. You should go to projectbabbage.com/docs, and you should read about how the Babbage system works and how you can create applications that use overlay networks as well as just using Bitcoin directly, and how you can do that properly. So thank you again for watching. This has been Ty Everett, the founding president of Project Babbage, and I wish you good luck as you go and build things on top of Bitcoin that respect privacy and facilitate a micropayment-based economy. Thank you.